So this is going to be lesson 1 of Unit 3, which is exponential equations and exponential functions. One thing that I do recommend reviewing for this unit is, you remember at the beginning of Unit 2, we did a little bit of work with rational exponents as well as exponent laws. If you could just go back and look at that stuff if you don't remember it right now. That's going to be lesson 2.0, review of exponent laws and fractions, as well as 2.1 rational expressions, or sorry, review of exponent laws and fractions. So I'd go back and look at that one. We also did rational exponents, right? When we were converting our radicals in that unit as well. So just go back and look at those two different things. So unit 1, lesson 4, simplifying radicals, where we talk about radicals and as well as exponent laws and rational expressions and rational exponents. That's again from lesson 1 and lesson 0 from unit 2. Okay, but to get started with this unit now, we're going to be going over our exponential equations. So an exponential equation is an equation where the unknown is actually in the exponent. So if you look here, the unknown is the exponent. Here, our exponent is the x, that is the value that we don't know. In order to solve an exponential equation, what you need to do is you need to express both sides of the equation as the same base, right? So you need to have it as the same base. When the powers are with the same base are equated, the exponents are equal, and equate the expressions to solve for the unknown. So for example, here you have a and a, they're both the same base, right? If you need a little bit of refresher, the a is the base here of the exponent, and this is the power or the exponent, right? So you want to have the same base for everything. If that's the case, then we can say that the two exponents are equal to each other. So for example, the one that I did with Hugh here is 5 to the power of x is equal to 125. So what we're going to do, and you'll know how to do this in a more like using a different type of function when we get into grade 12. For now, for the purposes of this course, what I want you to be able to do is I'm going to give you numbers that you'll kind of know. I know that 5 times 5 is equal to 25, right? And then I'm going to go into my calculator and I'm going to see, okay, can I do 25 times 5, right? Times 5 is going to give me 125. So I know that 5 to the power of 3 is equal to 125, right? So what I can say is I actually changed this 125 to something with the base 3. So we know that 125 can also be written as 5 to the power of 3. So now we can say that 5 to the power of x here is equal to 3. Okay? So that's how you're going to be kind of solving these ones. Again, when you get to next year, there's something that's called a logarithmic function that can help you figure out a different way to do this. But for the purposes of this course, you need to understand how to get there using this method that we have. So now we're going to see, okay, 4 to the power of what is going to equal 64? And you're going to change the 64 into base 4. Right? We're going to leave the 4x as is. So I know that 4 to the power of 4 is equal to 64. So I'm going to replace this 4 with 4 to the power of 4. And since x equals y, I know that x is equal to 4. Okay? I'm going to do the other ones, but if I were you, this would be, and if you need a little bit more practice and you need a little bit more understanding, that's completely okay. Just for, if you kind of get this, I want you to try doing B and C on your own, and then we will take them up. So if you could just pause the video here for yourself, right, and try to do B and C on your own before I take them up, just so that you will be able to understand how to do these questions. Okay, so I'm going to do B. Hopefully you paused the video and you went and tried it on your own. So again, We have 6x equals 1 over 36. So I want to see what would make this 1 over 36 to the base of 6, right? If I look at this, I know that 1 over 6 squared will give us 1 over 36. And I know that I can make this a base x by simply moving this from here to the top. And every time I move an exponent from the bottom, right, to somewhere it doesn't necessarily want to be, I just make um, the exponent in the bottom a negative, so it becomes -2. So I know that x is equal to -2. Okay. Same thing here. I want to see, okay, 9 and 27. So first things I'd like to try to keep the 9 as the base. 9 times 9 is going to give me 81. That's not even close to 27, so I know I'm going to have to change both of those bases. So the other thing that I can think of is that 9 can be square rooted to 3, right? 27 can be cube rooted to 3, so let's make this a base of 3, right? So 3 squared is going to give me 9. So I like to do this on the side here. So replace 9 with 3 squared, and 3 cubed equals 27. So sub these values in for the whole numbers we have here, and every time we sub, we always want to make sure we put in a bracket, and then continue to write the rest of the exponent. Plus, equals 27. Oh, sorry, 27 we replace with 3 to the power of 3, and we'll get that as x, right? And now we're just going to simplify these exponents, right? So we're going to do 3 squared. So we know that's going to be 2 times 3x plus 1 because it's the power to a power. And then we have 3x here, so I'm just going to distribute that 2 in. So 2 times 3 is 6x, 2 times 1 is 2, is equal to 3x. And now that it's pretty much simplified, right, I know that this base is the same as this base. Since the bases are the same, we can just go ahead, get rid of the bases and bring down the exponents and just work with the exponents. So I have 6x squared equals 3x, right? And now I just need to isolate for x. So I'm going to bring the 6x over to this side and take the 2 over to the other side. 6 minus 3 is going to give me 3x is equal to -2. Divide both sides by 3, right? And x is equal to -2 over 3. So if I was to go into my calculator and type in 9, 3 to the power of 2, -2 over 3 plus 1, it would give me the same thing as 27 to the power of -2 over 3. Okay? So knowing that, try doing D on your own, E on your own, as well as F on your own, and G as well, and we'll just take it up together. Okay? So for here, for D, what we're going to do is the same idea, except now that we have this 2 in front of here, it just complicates things. We want to get rid of that 2 so that it'll make our life a little bit easier, right? So let's get rid of the 2 on both sides. So if we cancel out this 2, we're left with 7x minus 2 is equal to 98 divided by 2 is just 49, right? And that makes things a little bit easier. I can replace this 49 with 7 squared, right? So 7x minus 2 is equal to 7 squared, right? And now that the bases here are the same, I can bring down the exponents. So I have x minus 2 is equal to 2, right? And I'm just going to substitute, or sorry, isolate for the 2. So I'm going to add 2 on both sides is equal to 2 plus 2 is 4. So x is equal to 4. And that's how you should answer. You should always just tell me what x is equal to, right? And now we're going to do E as well as F. So again, it's in your best interest to just go ahead and at least try these on your own. There isn't homework for this lesson, so please do stop and pause here and try to go through it by yourself. And then go check at the answers and see if you made a mistake. And if you made a mistake, you can go back and watch this video to see where you made a mistake. Okay? So we have 9x to the power of 4 and 27x minus 1. These ones, when you look at this stuff enough, you'll realize that 9 and 27, when you have them, you should use a base of 3. So I'm just going to go ahead and replace my 9 with 3 squared, x plus 4, and I'm going to go ahead and replace my 27 with 3 cubed. And again, these are just one of those things that we just know, right? Because we've been practicing. Equals 81. This again, I can replace with the base of 3 as well. So if I did 3 times 3 times 3, that's going to give me 27 times 3 is equal to 81, right? So I know that 3 to the power of 4 is what I'm going to replace the 81 with, right? And now what I'm going to do is I'm going to just go ahead, simplify this. So now I have 2x plus 8. I just distributed this 2 to the two numbers. Divided by 3, again, distribute the 3, 3x minus 1 equals 3 to the power of 4, right? And now what I can do is, because I have a base 3 here, I have a base 3 here, I have a base 3 here, I can actually just drop the exponents, drop the bases and deal with just the exponents. Just like you would, right? So now I have 2x plus 8 divided by 3x minus 1 is equal to 4, right? I'm just going to isolate. So now I'm going to take this 2x plus 8 equals 4, 3x minus 1, right? Let's do the math here. Distribute that in. So I have 12x minus 4, right? And then I'm just going to collect my like terms. So I'm going to bring them all to one side. I'm going to take the 8 to the other side. So I'm left with negative 10x equals negative, sorry, oops. Don't forget that this bottom one actually should be 3x minus 3. That was my fault. 3x minus 3. So if you had done that right, make sure that you keep doing that. So if it's 3x minus 3, this turns to 3x minus 3, right? 12x minus 12. So negative 12 minus 8 is negative 20, divided by negative 10, divided by negative 10. X is equal to 2. Okay, so that's going to be my answer there. A little bit more work. You got to do a little bit more to set it up, but at the end, it's pretty simple. It's just simplifying. So make sure you cross out everything and you're careful with your, try not to skip steps. So sometimes what I do is I try to skip steps and I make mistakes. So just like I did with the 3x minus 3, I tried to skip a step there and I ended up making a calculation error. So just be careful. All right, so let's try to do this one. It's a little bit more complicated. So if you tried this and you got this right, like power to you, you get it, right? But if you didn't, it's okay. So we have 8x squared equals 8x minus 2, right? So here we actually have the same bases. We can just bring down the exponents. So we have 8, oops, sorry, that should be 8 to the power of x squared, right? Same base, so you don't have to change anything. We're just going to bring down the exponents. Equals x minus 2. And this is where people get stuck, right? Is they don't realize that this is actually a quadratic function. So what you can do is you can bring them over to this side. Plus x. Oh, sorry, that should be minus x. Minus x plus 2, right? So now let's go ahead and see if I can even solve this, right? So I'm going to want to see what are two numbers that when we multiply them, right, will give us 2, right? So m times n. And you have to see, is there even numbers that will do this? Um, two numbers that when we multiply them together will give us 2, and when we add them together, m plus n will give us -1, right? So let's go ahead, see if we can even factor this. So two numbers, right? Negative x. And make sure this is why your signs really matter, because if you don't have the right signs, then it's going to be an issue. But I can't find two numbers that when we multiply them together will give us -2, and when we add them together will give us -1, right? So I was going to say, if this was a -2, you could have made it work when you brought it over, but because it wasn't, you can't factor this, no solution. For the sake of interest, I'm actually going to change this to a +2 just because I want to teach it to you that way as well. So I'll add this into your worksheet at the end. It's not on mine right now because I hadn't added it in, but let's change that to a +2. So I'm actually going to put this down here. So I'll make a new one, put it into your worksheet, and put it in as 8x squared equals 8x plus 2, right? And let's see if we can make that work. Okay, so again, we have the same basis, so we're going to have x squared equals x plus 2, right? So I'm going to have x squared minus x minus 2 is equal to 0, right? And if we factor these, we have 1 minus 2, so we have x plus 1, x minus 2 is equal to 0, right? So x is equal to -1, x is equal to +2. So now we have two possible values for x. So this is pretty level 4 type question. We're taking exponentials and we're inserting our quadratic in here as well. Okay. And one last one, again, pause. Try doing this one by yourself because if you actually understand how to do it, you should be able to do it. So I'm just gonna go in here and try and solve this one. So if I look at this, sorry. If I go look at this, I know that from both of these, what I can actually factor out is the 3x, right? So I'm going to pull out the 3x here. Then I'm left with, and this is like a thinking and inquiry type question, I'm left with 3x squared minus 1 is equal to 216. So what I'm actually going to do is I'm going to just go do that math in that bracket. So 3x squared is 9 minus 1, I'm left with 8, 216. Both sides, I'm going to get rid of the 8. So I'm left with 3x is equal to 216 divided by 8 is 27. 3x is equal to 27, we know is 3 cubed. X is equal to 3. Okay, and that's how you would go about that. You would just go ahead and factor out the 3x from there. Okay, and that is it for that lesson. So again, try going and doing these by yourself. That would be the best way to learn them. There isn't homework for this. You can move on to the next lesson, or you can work on your inverse function conference today. But that is it for today's lesson.